Good morning. Thanks for the invitation to speak at this workshop. I'm sorry I can't be in Shanghai in person to deliver it and also to interact with the other delegates. But anyway, the main theme of this talk will be the scoping of research in what I'm calling net zero road freight logistics. Net zero because it will consider the carbon sequestration as well as the carbon mitigation aspects of the subject, and logistics because it will look beyond the running of trucks on the road to the logistic systems within which freight is moved. This will allow me to report on several studies that I've done or contributed to over the past year or so, all of them now published and free to download. Most relate to logistics and freight transport in general, but in this presentation I'll try to focus on the implications for sustainable road freight research. The first of these studies is one which looks at the fundamental role that logistics will play in managing the climate crisis, arguing that there's more to logistics than decarbonisation. There's a journal paper been published on that, and there's also a guest post available on the Carbon Brief website. The second study was one done for the OECD International Transport Forum, related to their strategic infrastructure program for Asia. The first looked at freight decarbonisation. The second looked at the relationship between decarbonisation, connectivity, and resilience. The third study was one done for the World Bank, looking at how we can decarbonise logistics in lower income countries. Much of the focus there actually is on road freight operations, and the report is embellished with lots of photographs of trucks in the global south. The next study is one undertaken by Transporian with the support of my university and also the Smart Freight Group. This is a survey of many hundreds of carriers and shippers' experiences, both of decarbonisation and sustainability. And then the final study was one I did for a meeting of senior policymakers from EU member states, which was held in Antwerp earlier in the year. In a rather unusual venue. It was the zoo in Antwerp, and the discussions were held under a skeleton of a whale, which sounds rather bizarre. I'm arguing these days that logistics will have a fundamental role to play in the management of the climate crisis. Basically, that it will play 8 roles altogether. The first is that of being a cause. Logistics is a fairly carbon-intensive activity, but major efforts are underway to decarbonise it. It's also a victim of climate change. It's very vulnerable to extreme weather. It's an adapter because efforts are currently being made to climate-proof logistics systems and infrastructure. It's a facilitator because logistics will have a very important role to play in the decarbonisation and also the climate proofing of other activities and sectors. It's a rescuer. Climate is currently one of the main drivers of the growth and demand in humanitarian logistics, where we need logistics to help climate-stressed communities. But it will also be contributing to carbon sequestration. It will be a remover. Carbon sequestration at a planetary scale will involve the movement of vast amounts of material. And then finally, if our mitigation and sequestration efforts are proven adequate, we may ultimately have to resort to geoengineering, to what they call solar radiation management, which will again entail the movement and storage of lots of materials. First of all, looking at logistics as a cause of climate change, it's actually quite difficult to carbon footprint logistics as a whole, given the way data is presented. But from my work over the years, I reckon logistics accounts for between 11 and 12% of energy-related CO2 emissions. The vast majority of them coming from freight transport, as you can see, but also some from warehousing and terminals. To my knowledge, nobody has yet carbon footprinted the administrative and IT aspects of logistics, but if you reckon that's maybe around, say, 0.5%, it gets you to that figure. That means logistics emits around 4.2 billion tons of energy-related CO2 per annum. If it were a country, it would be the third after China and the United States. But these figures are an underestimate. For a start, because most of the freight emissions are calculated on a tank-to-wheel basis. If you transfer that into a sort of well-to-wheel basis, that would add probably about 19% more to those CO2 figures. And of course, the figures exclude emissions from other greenhouse gases like methane, nitrous oxide, refrigerant gases, which have global warming potentials much larger than that of CO2, and also black carbon, which comes from the exhaust of trucks as well. So if you factor all of these things into the calculations, you can see that logistics is a major contributor to the climate change problem. Zooming in on the road freight contribution to those emissions using a combination of IPCC and ITF data, we go from transport as a whole, accounting for about 23% of total energy-related CO2 emissions. The freight share of those emissions, roughly about 42%. The road share of those freight emissions, about 2/3 of them in total. And if you multiply all those percentages together, it suggests that road freight represents about 6.4% of energy-related CO2 emissions in total. And that splits roughly 1/3, 2/3 between urban freight movements and non-urban freight movements. And then, so that gives you an overall impression of the extent of the problem we have in trying to decarbonise road freight operations. If we look at the trends in road freight emissions using data from the International Energy Agency and the International Transport Forum, you get a sense of the challenge that we will have globally in getting those trends onto a net zero trajectory. Between 2000 and 2019, the compound annual growth rate of emissions from trucks was about 2.7%, significantly higher for heavy-duty trucks than for medium-duty ones. And IEA modelling suggests that to get onto that net zero trajectory after the pandemic, we needed an inflection point where the emissions would then trend downwards to 2030 at a rate of about minus 1.7% per annum. Clearly, that is going to be very difficult to achieve, particularly if the ITS recovery scenario for the period 2020 to 2030 were to materialise. That anticipates about a 1/3 growth in road tonne kilometres globally. If that were to happen, we would then need a huge reduction in the carbon intensity of road freight operations. But that is, again, unlikely to happen because the ITF anticipates that most of the future growth in road freight movement will be in non-OECD countries, where the average carbon intensity of freight is relatively high, much higher than it is, for example, in the EU, North America, and China. So the outlook, unfortunately, does not look very promising. To complicate matters further, we should perhaps be looking beyond exhaust emissions from the trucks to the embedded emissions in the roads along which they travel. This is something that I have attempted to do in one of the two ITF SIPA reports that I mentioned. Now, there's a large literature on the life cycle emissions from road infrastructure. There's one excellent review paper published in 2022 by Liu and others, which examines the range of estimates for greenhouse gas emissions for different stages in the life cycle of a truck. And those emissions are converted into carbon CO2 equivalent values. What it suggests is that obviously most of the emissions come from the construction related to earthworks, materials, and also from the maintenance of the asset during its life. The variations reflect a number of things: the topography of the country, the alignment of the road, the types of materials used, construction methods, and so forth. But it's worth noting that there is an important inverse relationship between infrastructural CO2 emissions and emissions from the freight traffic actually using the road, because if you build the road with greater capacity, there'll be less congestion and the vehicles will achieve more fuel efficient speeds. If you lower the gradients by, again, more earthworks, more tunnelling, or if you reduce the number of bends on the road, again, during the life of the road, you would find there'd be lower emissions from the vehicles using it. One thing I attempted to do was to estimate the share of road freight emissions that would be attributable to infrastructure if you made an integrated assessment of the two, combining the embedded road emissions with those coming from the vehicle exhaust pipes. You can see some of the numbers I used. I went for mid-range estimates really for these critical variables from the literature, and concluded in the end that the infrastructure share of the emissions would be relatively small, about 1.4% on average, though could be significantly higher in some regions and countries. It led me then to pose the question, if we were to start including the infrastructure emissions into the carbon footprinting of road freight, what impact might that have on freight decarbonisation policy initiatives? Moving on to logistics' second role, that of a decarboniser. Obviously, decarbonisation is where most of the research, business effort, public policy making has been concentrated. And in both the World Bank and the ITF reports, I review the various frameworks for analysing logistics and freight transport decarbonisation. And I conclude, surprise, surprise, that the best one, the one that seems to be most comprehensive and appropriate, is the 5-lever framework, with which I'm sure you're all familiar. The one which examines the measures we have to take to affect the demand for logistical activities, freight model split, utilisation of logistics assets, the energy efficiency of logistics, and then finally the carbon content of the energy that we use in logistics. And what I'll now do is use that 5-lever framework to examine progress in the mitigation of carbon emissions from trucking operations in the EU. Looking at the first lever relating to the demand for freight movement, there is little evidence of the growth in freight movement in the EU reducing or slowing. The EU's reference scenario, their main forecast, is for about a 27% increase in freight ton kilometres by all modes between 2020 and 2030. Obviously, the pandemic caused a brief interlude in the upward trend, both in GDP and ton kilometres. But since 2021, we've seen the previous trends re-establish. There remains fairly tight coupling of freight ton kilometres and GDP in the EU. And so there's little evidence, as I say, as yet of that trend slackening. If the EU's current cohesion policies prove effective, then what we might see is longer haul freight movements to more peripheral regions. There are also predictions that we'll see some reshoring of production from low labour cost countries to the EU, which again would increase the freight transport intensity of the EU economy. So if these things were to happen, then we might actually see freight ton kilometres growing faster than GDP. But then in the longer term, you've got to take account of a whole range of other factors which will influence future freight demand. Some of them will depress demand for freight transport, making the economy more circular, dematerializing some products. Obviously, the fossil fuel phase out is going to reduce the amount of oil, coal and gas transported. 3D printing might also make a contribution. But on the other side, there are other developments which will be major drivers, it seems to me, of future freight transport demand, some of which I'll be talking about in a few moments, like putting in place a renewable energy infrastructure. Adapting to climate change is going to involve the movement of a lot of materials, and also carbon sequestration will as well. So it's currently a difficult task trying to make long-term projections of freight demand in Europe. Moving to the second lever, that of modal shift. In Europe, the forecasts are actually quite optimistic about the growth of rail freight movements, increasing by about 71%, they reckon, between 2020 and 2040. But despite that, they reckon that will still only leave the railways with about a 19% share of the European freight market. And if one looks at recent trends from 2012 to 2022, what you find is that modal shift has been going, in environmental terms, in the wrong direction, that the road network has been increasing its share of total freight kilometres, and indeed in 2022, the European road network had its highest ever share of freight ton kilometres. The European Commission has also been criticised for setting targets for modal shift which are just overambitious. The European Court of Auditors, in a report published last year, said this. They said the Commission was setting unrealistic targets for 2030 and 2050 for the increased use of rail and inland waterways for the transport of freight. These targets were not based on robust simulations of how much modal shift could be achieved. And the challenges of getting more freight onto rail and waterways is not just confined to the EU. There was a study published in 2022 by the International Transport Forum, which some of you may be aware of. They looked at 51 countries around the world over a 40-year period, and they found that only 3 countries had managed to reduce the dependence on road freight over that period. I think the 3, if I can recall, were Italy, Slovenia, and Montenegro. And this is an illustration of what I call logistical lock-in to trucking. It's so difficult, really, for policymakers to redistribute freight between the different transport modes. One development in Europe, however, which may help achieve this, is the imposition of carbon pricing on trucking operations. Germany led the way in December last year when they introduced a carbon charge to the toll which trucks pay in Germany when they travel on the Autobahn network. This valued carbon at about 200 euros a tonne, translated into a 12.4 euro cent additional charge per kilometre on trucks. That was a 69% increase in the toll. And actually much of the revenue that will raise will go towards providing financial support for infrastructure improvements on the rail network in Germany. And then looking to 2027, the European Commission will be bringing road haulage into its emissions trading scheme with what they call ETS2. They're not monetizing CO2 at quite such a high value. It will be limited to about 45 euros per tonne of CO2. But once this is implemented, it's going to inflate the cost of road haulage in Europe, and other things being equal, that may have the effect of pushing more freight onto the railways or waterway network. In the case of the third lever, the utilisation of road freight capacity, I've been complaining for decades about the lack of macro-level data on capacity utilisation, which makes it very difficult to do research in this area. The only data we tend to have relates to empty running, and if one looks at the European situation, it's rather disappointing that we have seen only a marginal reduction in empty running over recent years since 2010, despite the fact that we've seen digitalisation of road freight markets, we've seen big efforts to promote greater asset sharing across supply chains, and because of the commercial benefits that companies would get from reducing empty running. So this is a major problem I think we need to address more fully. Then shifting from Europe to the situation in lower income countries, where the problem is of an overloading of vehicles, which again can carry a carbon penalty because the engines are labouring and because of the damage done to the road pavement. In my report for the World Bank, I conduct a root cause analysis of trying to explain why it is that truck overloading is so endemic in these countries. And it seems to me, again, this is a subject that requires more research. On a more positive note, we've seen about a 20% improvement in the overall energy efficiency of road freight movements in Europe since 2000. And it's likely that trend will continue as a result of the imposition of fuel and CO2 efficiency standards for new trucks in Europe. They were tightened in 2023. These are not simply fuel efficiency standards. They take account also of the transition to a new generation of lower carbon vehicles. But this is a longer term development because, as you can see, at the current rate of replacement, the entire EU truck fleet won't be replaced for about another 15 to 20 years. In the meantime, of course, there are many things that businesses can do to improve the fuel efficiency of their operations. This was monitored by the Transporian Green Freight survey. In excess of 500 carriers contributed to the survey, indicating what they thought was the relative importance of a whole range of truck fuel efficiency measures. There they are on this graph. What surprised me was that the more vehicle-specific technical ones were so well down that list. But nevertheless, I think there's a good news story here overall. And then the fifth lever, relating to the transition to a new generation of low-carbon vehicles. This will be a slow transition, it seems to me, because of the challenge we will have in coordinating the development of new transport and energy infrastructures, the manufacture of a whole new generation of low-carbon vehicles, and also linking that to the operator's vehicle replacement cycle. There's a snapshot of the European truck market in the first quarter of 2024. With, as you can see, a very, very small percentage of vehicles, the battery electric vehicles being purchased, particularly in the heavy duty sector. But then we will have to see a dramatic ramp up of the sales of these low carbon vehicles in the near future if we are to stand any chance of reaching the EU's target for the truck sales market in 2030. The Green Freight survey I've mentioned earlier sheds some light on what the main barriers are to this transition, where a large sample of carriers and shippers were asked what is currently restraining this. If you look at the list, I'm sure you're well familiar with most of these barriers, dominated by the cost of the vehicles being too high, the lack of recharging infrastructure, just lack of availability of new vehicles. But if you put all that together, given the time it's going to take us to transition to these vehicles, I always argue we should be placing greater emphasis on the other four levers, which we can do in the short to medium term, and which will also help to reduce the amount of energy that we will ultimately have to defossilize. Moving on hurriedly to logistics' third role as a victim of climate change, I would argue that few activities are as exposed to climate risk as road freight logistics, partly because they're so geographically extensive, because of the close interconnection between logistical facilities, but also these days their time sensitivity in a world which is essentially governed by just-in-time. What I've tried to do in this diagram is encapsulate all the main elements in this, the three primary weather variables, the logistics assets which are exposed to the risk, and then the various geophysical impacts that extreme weather will have, and also how this can be indirectly affected by the dependence of logistics on energy and communication infrastructures. This leads me to a piece of analysis I did for the ITF SIPA project, which has just been published, where I look at the interrelationship between decarbonisation, resilience and connectivity in the development of freight transport systems. What I did was identify 35 different interconnections between the three entities, and what I then did was to rate them into three categories. The ones which are synergistic, where the developments are mutually reinforcing, the ones where there's a conflict and one therefore has to trade off, and then a series of what I call hybrid relationships, which can either be conflicting or synergistic depending on local circumstances. And the good news is that it seems to me about 2/3 of the interdependencies between these three entities are actually synergistic and mutually reinforcing. Another part of that study identified 58 different metrics that could be used if one wanted to conduct a quantitative macro level analysis of these interrelationships. I mean, the work I did was essentially qualitative and subjective, but if anyone is interested, there's a potential, I think, to take this to the next stage and try to quantify some of these interrelationships. The next role of logistics is as what I call an adapter, because it's an activity which is in desperate need of climate change adaptation. Despite that, however, if one looks at the IPCC Sixth Assessment Report on Adaptation and Vulnerability, 3,068 pages long, makes only 3 very brief references to the vulnerability and adaptation of logistics systems. Now, there is a huge literature on the adaptation and climate proofing of transport infrastructure, and much of that actually focuses on road infrastructure. But what is lacking currently is research on the adaptation of road freight operations and logistical systems as a whole to climate change. And there's been studies done on this. One study in 2019 claimed that logistics and supply chains were what they called adaptation blind spots within the private sector. So this is an area where we need an awful lot more attention. Logistics' next role is as a facilitator, in other words, facilitating the decarbonisation and also the climate proofing of other activities. Now, this can be illustrated, I think, in the case of the energy transition, because what we're having to do worldwide is create a new renewable energy infrastructure, which is very material and transport intensive. For one thing, the amount of materials you require for that infrastructure per tons of product per megawatt of energy, if one just compares wind power with coal, nuclear and gas, you can see how the average amounts of steel and concrete required is much higher for renewable energy. Of course, once that renewable energy infrastructure is in place, you don't then have to move all the fossil fuel. But putting in place involves the movement of a lot of structural materials, as you can see a forecast there for the demand for these materials by 2030 in Europe. Also, renewable energy generation is much more geographically dispersed, again, which is going to impose a heavy burden on the road freight sector. If we look at the case of Germany in 2022, it took 1,055 wind turbines to produce as much electrical power as the country's largest coal-fired power station, one called Schoven in Gelsenkirchen. An illustration of the different geography, if you like, of renewable energy generation. Also, the wind turbines, the solar panels, the hydropower, they require materials brought through global supply chains, lithium, cobalt, batteries, and so forth. Again, a transport-intensive process. And the other thing is that a lot of the equipment that we require for renewable power generation is out of gauge in the sense that it doesn't fit neatly onto a truck or a ship or whatever. So this complicates the logistical task involved. Then there's logistics' fundamental role in the carbon sequestration process. All the IPCC 1.5 degree pathways now include substantial amounts of carbon dioxide removal. Between 4 and 9 billion tons of CO2 may have to be removed from the atmosphere annually by the 2050s. And this can be done in various ways using nature-based methods or various mechanical and chemical processes, or a combination of them both in the sort of so-called hybrid measures. To date, the logistical requirements of these processes have not been fully quantified, but preliminary analysis suggests that they will all be very freight transport intensive. Now, the movement of the captured CO2 for long-term storage and geological formations and disused oil wells, for example, will almost certainly be by pipeline and by sea. But the road freight sector, I think, will be heavily involved in other flows of materials and products in the carbon dioxide removal supply chains. So to conclude, what I'm arguing for is a broadening of the scope of not just research, but business strategy, public policy making, recognising the multiple roles that logistics will play in the climate crisis. Why should we do this? Well, one thing is to understand the interaction between all the various roles that I've described. Must commend the UK National Highways Organisation here, because in its documentation, it does look at the interrelationship between its efforts to decarbonise its operations and also the adaptation of road infrastructure. We also have to assess the logistical feasibility of some of the current proposals for climate change adaptation and carbon dioxide removal. And also in research terms, we need to recalibrate a lot of our freight models to take into account what I'm calling climate logistics traffic, because much of the modelling work currently doesn't take account of all this additional freight movement. I should also point out that there are probably exciting new business opportunities for logistics service providers here, because there's going to be a big increase in the demand for freight transport and for storage for these purposes. And also, logistics service providers could potentially diversify into new activities in the areas of facilitation, adaptation, and even carbon sequestration. But despite what happens, none of this should distract us clearly from our primary goals of trying to decarbonise activities, particularly road freight transport, and also to improve their climate resilience. So I hope you found this presentation of interest, and I'll be happy to answer any questions you may have if necessary by email. Thank you very much.